By the way, let me introduce Renard. Renard Spratling is the department head for the IT department here. He is manning the chat box while I am playing the host. So if somebody is paying attention to the chat and can help you out if you are having any sort of little technical glitch. So Renard is there for you.
Hello, everyone.
All right. So our two presenters today are both from IBM. Lisa Thaller is the worldwide pricing and investment manager for IBM Storage Brand. They have over $3 billion of revenue each year. She has over 30 years corporate experience in financial analysis and planning. She has lived in Burlington for over 20 years, and all 5 of her children have graduated from Walter Williams High School. She's involved with the Christmas cheer organization in Alamance County. So she is our Alamance person here. She is
homeboy.
She has helped our school many times. She's worked with our IT department for many years now, and we're really grateful for her expertise she brings. Eliza is a data scientist for the IBM's Financial Crimes Insight. She has special interest in extracting actionable insights from complex patterns that are emerging in financial data. That's a very big deal. Eliza holds a master's degree in analytics from NC State University and a bachelor's from UNC Chapel Hill. Welcome to both of you. We are excited to have you both here.
Thank you for having us.
Thank you. We're excited too. Thank you, Laura. So do you want me to go ahead, Laura, and start sharing my screen and just dive right into it, right? So hello, everyone. And like Laura said, I have been at least coming around the ACC campus for a few years now, volunteering through IBM's programs where we work with community colleges. So some of you may have seen me on campus. That might have been a year or 2 ago, but so what I've done today here is we put together a presentation. I'm just going to take you through some slides. First, I'm going to talk about an IBM overview and the history of IBM. Then I'm going to talk to you about my role, how I got here, kind of what I do. Then I'm going to turn it over to Eliza to talk about data science at IBM, how she got here, what she does, and what the Financial Crimes Insight Group does. And if anyone has a question and you want to jump in and ask me, please feel free to go ahead and ask me a question. So a lot of times, one time I went to a job fair, and now granted, this was at a high school, and everybody had tables, and IBM had a table there, and all the students that came up, I would say only about 5 or 10% of the high school students even knew what IBM was. So I feel like in some settings, I need to kind of refresh everybody's memory of what IBM is. It was founded in 1911, and we have all sorts of technology products, hardware, software, cloud-based, cognitive computing, quantum computing. In 2020, we were within the top 10 of big tech companies. People many times think of Amazon, Google, Microsoft. They don't even think about IBM. Another interesting trivia is that the campus in RTP, North Carolina, is the largest IBM US location. It fluctuates. It's been as much as 15,000 employees there at one time, but it still is the largest US IBM location. I wanted to give you guys a flavor of IBM, so I'm going to give you their purposes and their principles. IBM's purpose is to be essential, and IBM has wide-ranging impacts in many different areas, from doing consulting work with the government to Watson Health, all sorts of different things that they work with. Then we have these values: dedication to every client's success, innovation that matters for our company and the world, and trust and personal responsibility in all relationships. One of the reasons I wanted to put this on here is, as I tell my adult children, when you go to look for your career, look for a corporation that has the values and things that you want to see in an organization. So it's always good to know what they stand for. Now, I put together a little IBM trivia kind of game here. So for those of you old enough to have seen the movie 2001: A Space Odyssey, in the story, there's this AI computer that kind of takes over. His name is Hal. Hal, H-A-L, was named because those are the letters right before IBM. Way back in the day, IBM was like the big tech company. We even had an antitrust suit. So it's been around for a long time. Okay, IBM has had a lot of inventions. Floppy disk and the hard disk drive, the magnetic stripe card, barcodes and the scanners, the relational database, SQL programming language, and DRAM. And again, a lot of people don't realize how long IBM has been around and some of the foundational work that we have done. It's also very far-reaching in terms of the transactions in this country and the world that flow on IBM's hardware, software, and services. 96 of the top 100 banks use our products, 9 out of the top largest insurance companies, and 23 of the largest retailers use IBM mainframes. And yes, there are still mainframes out there. So again, I just wanted to give people a flavor of what IBM is and what we do. Okay, here's another thing that I think is very interesting. IBM has topped the US patent list for 28 consecutive years. That's not like just, here and there. I'm sure there are people on this line who have not even been alive for 28 years. But they received over 9,000 in 2020. And you can see that we led the industry in multiple areas. AI, 2,300 patents in AI, 3,000 patents in cloud and hybrid technologies. I'm sure you guys have heard about quantum computing. I mean, it was interesting to me. I sat through an IBM presentation on quantum computing and they showed a picture of the actual device. And it was odd. It was kind of like in this glass box. And it was like the thing was floating in the middle. And it, again, thinking of like a sci-fi movie, it really looked to me like something you'd see in a sci-fi movie. And security. I know IBM, as well as out in the country, you will hear me talk about cybersecurity and the skills gap in cybersecurity. IBM had over 1,400 security-related patents. So that's another area that we're focused on. Okay, so that's kind of what IBM is and what we do. Now I'll tell you a little bit about what I do at IBM and how I got here. So I'm the worldwide pricing manager for now, Laura, I gave you $3 billion. They just gave me a second department. So now I'm overseeing $5 billion of IBM hardware, software, and services. And the way I describe it to people, it's hard when you say, what is a pricing manager? And I use an analogy. Let's pretend I work for Ford. If I worked for Ford, what I would be doing is Ford wants to come out with a new truck, an F450. Well, first of all, you've got to see, how much money will it cost to develop that truck? What is the market opportunity? What can you sell that truck for out in the market? And then decide financially, is it worth it? Then the other side of my role is you go to a Ford dealer and you will talk to a salesperson, and that salesperson will say, if you want a lower price, I have to go ask my manager if I can get that lower price. Well, my team is that manager where if somebody in the world, and I do this worldwide, my team does it worldwide, somebody around the world wants to sell an IBM product at a really low price, they have to come ask my team for that as well. So I try to put it in a more real world kind of analogy. And what we're trying to do, of course, is maximize IBM revenue, cash flow, and again, return on investment. And I'll tell you guys this, I was involved in a product at IBM. We invested 85 million of development expense, and it ended up the product just never sold. So it is very important to understand investments and whether or not that product will actually be successful. I graduated from the University of Georgia with a major in accounting. I started right after, I graduated in Atlanta, and then I moved to RTP, North Carolina. That was a long, long time ago. I've been in Burlington for 20 years. And like I said, all 5 of my children graduated from Williams High School. So I definitely have a soft spot for ACC in Burlington. Okay. Now, what do I do on a daily basis? When I was thinking about this, I thought, what I really do is I solve puzzles and I paint pictures. And I know that might sound like an odd way of stating it, but all of us, the reason we are at work is there is some puzzle or there is something that the corporation or the organization is asking you to do. And it can be wide ranging. Eliza's hard skills are going to be very different than my hard skills, but we're both here to solve a puzzle. Some of the puzzles I'll give you a few examples. Why are we not charging as much for our product in China as we charge in Germany? And are there different competitors that we're facing? That would be the puzzle. But then I have to paint the picture and explain it, explain the problem, and explain the solution to everyone around me. And that really is something of an art. There's science to solving a puzzle, but then you need the art to be able to tell people what's going on and why your solution is the best. So that's kind of, again, just a very brief snapshot of what I do and how I got to IBM. I've been here for a long time, like Laura said. So I think I'm going to just pause real quick, if you guys don't mind, and see if there are any questions before I turn it over to Eliza. Any questions or comments before we go on?
I have one. Can I ask my
Okay, sure.
What has been the biggest help in managing the different personalities that you have to deal with in your position? Because you're international as well as local, so you're dealing with different perspectives and people in different places in the world at all times.
Okay, so that's where I have been a big advocate, and I've done a lot of, I guess I'll call it studying and work on emotional intelligence to be able to understand other people. But you're right, culturally, it's very interesting. I saw a graph where they took a survey in multiple countries and they said, basically, if I ask you to do a problem, will you be able to solve it? In the United States, everybody was very, very confident. 90% of the people said, yeah, I'll be able to solve that problem. But depending on the country, that culture, many cultures don't automatically say, oh yeah, give me a problem and I'll solve it. You have to learn, I've had to learn dealing with my colleagues in Asia versus dealing with my colleagues in Europe, how to ask them a question or how to give them direction. Some cultures have much more, they look to authority more than other cultures. It is the easiest way for me to say it. But that my answer to your question, Laura, is to understand emotional intelligence.
And then one more quick question for me is, what was the biggest help in developing these skills that you needed to solve your puzzles every day? Like a skill set. What was the biggest thing that helped you develop those skills?
Necessity is the mother of invention. So I would say, you're put in a job and they will say to you, here's how you do your job. But if you're given these puzzles and you figure out things like, of course, me in finance, Excel has been my tool, right? Figuring out, I mean, really, it came down to, Laura, going out and trying to find better tools for myself. So some of it just came down to looking or asking to find the best one.
And I wanted to point out Excel. Excel is used everywhere for those who are students now. Pay attention in your Excel classes, especially if you're going into industry. My friends that work in any corporate job, they can program Excel exceedingly well. Excel is a powerful tool, so pay attention when you're in CTS. I think it's 130, Renard, if I'm wrong, let me know.
Yes, that is
Okay.
correct.
But pay attention in Excel because it is a powerful tool. That's just a little slide that I have.
But I would say, Laura, and I'm going to kind of speak to the same students, while you're learning Excel and learning PowerPoint, keep a mind towards the painting. You can make beautiful graphs in either of those tools. My experience in the corporate world is being able to communicate simply your answer, and those tools give you the ability to create a beautiful picture. I mean, highlighting, colors, etc. Think about that when you're in your Excel class too.
Yes, keep it simple.
Yeah.
One quick question from the chat. Who are the buyers of your patents?
Oh, IBM holds those patents. We do have some IP agreements, intellectual property agreements, where other companies will pay us a licensing fee to use our technology, but we do not sell our patents to other companies. We keep them for the great value that they are. That's a great question, whoever asked it. And I'm sure people have heard about intellectual property and, you know, the issues with when a company invests the amount of money to create a patent. If another company goes and steals it, that's a pretty big deal. So we try to milk that cash cow. Okay, anything else for me before I turned over to Eliza? Okay, if not, I'll turn it over to you, Eliza, and let me know when you want me to flip the slides.
That sounds great. If y'all can't hear me all right, just kind of give me a thumbs up and I'll try and speak louder or plug my headset in. But I am Eliza. I am a data scientist at IBM and I work on the Financial Crimes Insight product team. So if we go to the next slide. Today, I thought it might be good to just kind of chat through what my journey to data science looked like. Give an overview of the field of data science. There's so many different interpretations. It's a very intersectional area, so there are a lot of perspectives of what it can cover, and then talk about how data science is being applied on the Financial Crimes Insight team. So if we go to the next slide, we'll kick it off with my own personal journey. I earned a bachelor's at UNC Chapel Hill, as Laura mentioned, in public policy in 2015. So I originally came from the world of social sciences. I was not as involved in the STEM fields, but there's a section of public policy that uses data to try and understand its constituents, their needs, and how those needs can be met with the resources available. And going through that quantitative process of trying to crunch those numbers, I realized how much I really enjoyed engaging with data to try and leverage it to create more actionable insights. And because of that, I decided to kind of make a career pivot and move more towards the STEM fields. And in doing so, if you hit next, I had to take some time and go back and do several prerequisite classes, statistics, some basics in programming. And in doing so, I got a certificate at NC State in applied statistics and data management. So I did that while working. And it was that education that allowed me to then pursue a master's at NC State in analytics. So I went to the Institute for Advanced Analytics. It is local to the RTP area. It's done by the Institute for Advanced Analytics. So they're kind of this this combination of different departments that teaches you a wide range of skills. It's a one-year program, which can be really helpful if you are looking to gain that knowledge and education, but not be in school for a long amount of time. And after I graduated in 2018, I came to IBM. So if you hit next, I started the job that I am now, still currently in, with the Financial Crimes Insight team. And I've been a data scientist with them for the last about 2.5 years now. Now, if we go to the next slide, it might be useful to just kind of talk through what data science is. So it is this field that is a combination of a lot of different skill sets. There are different ways to interpret it, but one of the most common visual representations is this Venn diagram. You'll see lots of versions if you Google it, and it combines mathematics and statistics, computer science, and some of those softer skills of the business acumen and the ability to communicate and tell a story. So if we hit next just a couple times, we can see there are some different positions when you find those overlaps in, for instance, computer science and mathematics statistics. That individual might be seen as a machine learning engineer. Someone who combines the math with the business, they might be someone that you think of more as a traditional researcher or an analyst. And the computer science business overlap is a application or product developer. And these are all roles that a data scientist might engage in and share responsibilities and qualities with. Often you'll see the data scientist fit somehow in the overlap right in the middle of the three different circles. And depending on the job, on the necessity, they might be pulled one into one direction or another a little bit more, but overall they're gonna have some combination of those skills. So if we hit next, I just kind of wanted to put on the screen a couple of different examples of some of the educational backgrounds of individuals that I have worked with who are now data scientists. So up on the top of the screen, there's some that come from the world of information technology. They have degrees in computer engineering. You know, we might associate that more with computer science and see how that path evolved. On the bottom left of the screen, there are several that have come from the world of biology, environmental studies, or math and science. The bottom right side, I think, tells a really interesting story about how data science is so diverse in the skills and backgrounds of those that come to work in that field. We'll see people with backgrounds in consulting, in psychology, or public policy, such as myself. There was someone that I knew who was a data scientist that had a background and an education in theater, and they were able to leverage that knowledge to become a data scientist for movie theaters. There's also a really big presence of individuals with a background in linguistics, so the studying of language, in the data science world, because they're able to use all of that knowledge that they already have to apply it to a practice called natural language processing, or NLP, where you're looking at text, whether it be some kind of customer review, social media posts, anything like that, to try and break it down and understand, help the computer understand what message is being given in that language entry. So there's a wide variety of ways that someone can be involved and enter the data science world. And I think that's what makes it so exciting and such a really fun area to work in. So if we hit the next button, and I'm keeping an eye on the chat. I haven't seen anything come up yet, but at any point, feel free to shout out questions. I have a gradient here, kind of a scale or spectrum of different individuals that are going to be involved in the analytics process. So on the left side of the screen, you'll see the roles that are maybe a little bit more business centered and a little bit less technical driven. Shifting to on the right side, those are the individuals that are going to have a deep focus in the technical coding software side, and they might be a little bit more removed from the communication and the business aspects. And it's not a hard or fast rule, but this is kind of a nice way to help conceptualize the roles. So we see business analyst, data scientist, data engineer, and software engineer. Quite a variety of different roles that are involved in the production of analytics. Now, to kind of help understand how these roles came about, there are a couple different perspectives. You can find various articles on the internet. One that's really great is done by a site called KV Nuggets, where they talk about the waves of data science and the evolution of this field. So I've tried to just kind of synthesize it down here. If we hit next, We see that the first wave comes up, we hit next one more time. This was, you can kind of conceptualize it as pre-2010. So you had a lot of statisticians, a lot of very specialized professionals, and they were really deep in the work of helping to develop a lot of the machine learning algorithms that we know and love today. As we move to the next wave, we hit the next button, the second wave, if you so choose to conceptualize it like that. It was a lot of the 2010s. And this is kind of where we start to see the emergence of the data scientist. And it was really kind of punctuated by this idea of creating what are called proof of concepts, where you'll write up code, maybe put a model together to show how data science can add value to a business user. You see a lot of open source languages being used more and more instead of some of the private languages that were developed and used in the first wave. But we noticed in the second wave that there was a need to really start to productize the work that was being done, which gives way to the third wave. So if we hit next, we see that the third wave maybe starts around 2017, give or take a little bit onwards. And it is defined by needing to productize, scale, and deploy the data science techniques that were being widely worked on during the second wave. So instead of having a data scientist such as myself sit down and code and hit submit and pull out a graph and directly hand it to a client, they wanted to make that process run more smoothly. While data scientists might be involved in the creation of that flow, we don't want to always be requiring data scientists to be hands-on. Right? You might want to run something overnight and I'm going to go to bed and you don't want to be dependent on my sleep schedule to get your numbers out. So the third wave is really working to combat that and make it scalable and efficient. You've got logging coming out, monitoring, and the modularity of code. So if we hit the next button, in understanding how all of these different elements have played a part in the world of analytics over the last several years, we'll find often that data analysts, data scientists, and data engineers, while they each have their own kind of role or identity, they may often be treated as a profession or a professional that can do the responsibilities of the other. We see a lot of overlap in them. And so it's really important, I think, when you are entering this field to have an understanding of what these different roles look like and which one you might gravitate towards the most, but also realize that every organization is going to have their own definition and they might combine all three together, or they might have very siloed and specific roles. And that's a really good thing to kind of pay attention to as you are considering whether an organization and their analytics approach is the right match for you. So while they can kind of be seen as the same person, I thought it might be helpful just to put a couple definitions out there. So if we hit next, to facilitate the conversation of how one differs from the other. So an analyst, you're going to see them really involved in kind of diagnosing different trends. So they're doing descriptive and diagnostic analytics. Descriptive is when you're trying to understand changes that have happened. So you might look at data from the last 5 years and see, oh, okay, this year there were 20 books sold, this year there were 30 books sold, this year 40. They'll also do diagnostic analytics, which is trying to explain why something happened. So not only we went 20 to 30 to 40, but why was there that increase? They really help in the storytelling process. They are involved in creating dashboards, reports, visualizations. And I've listed a couple, none of these are comprehensive, but some of the tools that I will most often engage with are SQL, Excel, and Python. The data scientist, kind of in the middle of that business to technical spectrum, you're going to see them engaging a lot with the machine learning practices. So they'll be engaging with predictive and prescriptive analytics. So predictive is what's most likely to happen in the future. So instead of looking back and saying, okay, there were 40 books last year that were sold, we want to predict how many books are being sold this year. Prescriptive analytics is going to look in the future and try and generate recommendations or actions to take relative to some kind of predicted outcome. So you can think about self-driving cars. That might be a good representation of that. And data scientists, they're doing a lot of algorithm training. They might also help with some of the reports and pulling out metrics as to how good your model is. And a lot of languages that you'll see them use are Python, PySpark, R, Scala, and they might have to engage with HDP or AWS if they're working with big data. And then finally, the data engineers, they might be more likely to be involved in developing kind of the standards for what production looks like, what modularity looks like. So just as we talked about with that third wave of the data science world, they are really helping to make sure everything is efficient and scalable. They're also the ones that are most likely to first engage with raw, unformatted data that has different errors. So maybe it's a data entry error and someone, when they were typing in a customer's name, typed it wrong. Well, the data engineer is probably going to be the first one to see that. Or maybe there's lots of missing fields. If you're joining two tables and it creates a completely null record, which is going to make the models really upset, the data engineer might be the one that first realizes it and tries to address it. They will often use languages and tools such as Scala, Java, MongoDB, Hive. You'll also see them using Python as well. So these are some ways that we can kind of profile each of the roles, but we also realize that there are many times where they are all kind of mushed together into one person. For instance, on my team, we have data engineers and we have data scientists, so there is a delineation there in those roles, but we don't have data analysts. So when there's a need for visualizations or reporting, the data scientists will often step in and cover those needs. So if we move to the next slide, we can take this data science conversation and focus it a little bit more on IBM's financial crimes insight. So this is the software team that I am a part of. We try to create a product that is packaged and shipped out to customers that addresses different types of financial crimes. So the two domains that I am the most involved in are the anti-money laundering area and the insurance fraud. Oh, I think I just saw a question. Is your operating platform mainly Windows, Unix, or some other proprietary environment? So I have seen all three, Windows, Unix, Macs being used by development from my side of IBM. Lisa, I don't know if you have a different perspective, but I've seen all three of them used.
I don't have a different perspective. You would probably know more about that than me.
Yeah, I've each has their own place, and I've seen all three leverage. That's a great question. So we try to create a software product that ingests data that is obviously financial in nature. It tries to merge different tables together, clean the data. So just like we were talking about, the data engineers might find data entry problems, there might be null rows, weird anomalies popping up. We try to address those. That data will be passed to the kind of data science section of the full pipeline, where we run different models trying to predict whether new financial behavior is suspicious or not. And then all of that analysis, the prediction of whether it is or is not suspicious, maybe why we came to that prediction, is then put onto a screen in on the UI for end users to be able to walk through all of the different insights and make business decisions for themselves with the aid of the knowledge that we provide. So as a data scientist, I kind of sit in the middle of that pipeline and try to work on algorithms that will detect the patterns of suspicious behavior. So just kind of walking through, and I'm sure everybody is aware, but money laundering will often see that defined as when an individual or group is taking funds with maybe a bit of a nefarious origin or background, and they're trying to clean or launder them to conceal the source of the money and potentially the destination of the money. Insurance fraud is where someone or a group is purposely kind of trying to deceive the insurance company with the hopes that it'll result in some kind of advantageous, there we go, or financial gain. So there are lots of different patterns in which these financial crimes are executed. And the hope is that our machine learning algorithms can learn what those patterns are and how to detect them. So for instance, in the world of money laundering, there are different schemes and approaches that are used. For insurance fraud, I assume that your clients are major insurers, or who are your customers for, let's see, let me pop the chat out, for areas of financial crime analysis. Right, so the great thing about this product is that really if there is someone who has, or an organization that has data that's financial in nature, it is applicable to them. Obviously specific customer names we won't go into, but there are lots of different organizations in the money laundering domain and the insurance fraud domain that their work is relevant to what we produce. And yes. So we will try and find some of the patterns that are in the financial crime data. Some common approaches, there's one that's called structuring. So that is when someone will try to alter their transactions, and particularly, for instance, cash deposits, so that they don't have to report to, in this instance, a bank, where that money came from. So we'll often see if you have a cash deposit of greater than $10,000, there is a requirement to file a report, and it kind of goes through and explains where you got this money. And if the money has a nefarious background, you might not want to be directly reporting where you got it. Thus the need to try and structure and avoid that report. One way that you might try and avoid that report is what we call smurfing. So just like the little Smurfs that you'll see in the cartoons, you will have multiple individuals or parties involved that are going to go to different banks or financial institutions to try and deposit money at amounts, if it's, you know, this cash greater than 10,000 example, deposit their cash in a threshold less than 10,000 so they don't have to report, and work those funds back to the original holder of them. And so these are some of the patterns that are known in the world of financial crimes, and our hope is that as we train algorithms, they'll be able to detect when some of these things are happening and create a prediction where it's saying, yes, it's pretty likely that this does not check out. You know, we need a professional to go in and look more deeply at it. So that's kind of what the goal is of the data science work. So a lot of that requires historical training data, so data where the events have already occurred and we know what the outcome is. So someone has looked at this group of data, whether it be money laundering or insurance fraud, and they've said, yes, you know, indeed, this was not okay, or they say, oh, actually, there was a really reasonable explanation. We take that historical data where there's some kind of diagnosis of a yes or no, and we're able to train our models on it. Once we have those models trained, we're able to take new kind of current day data where someone hasn't gone in and said yes or no, and run it through the models to get a prediction. That prediction, if severe enough, is given to professionals to go in and do that more manual yes or no diagnosing. So all of this to say, we do both product work in the software spectrum, and we'll sometimes engage in proof of concept. So you'll see both that second wave and third wave process coming about. So if we go to the next slide, just a little bit more of a detailed technical breakdown of the work of the data scientist on IBM's FCI team. We are predicting a numerical classification. So it the models that we're using, you know, they can't read if someone writes, yes, this is fraud, or yes, this is money laundering. We instead need to take those and recode them into ones and zeros or twos, or however the numeric representation of all the possible outcomes are going to be. And we can feed that through unsupervised and supervised models. So unsupervised is when you don't need to know what the outcome was. It doesn't really matter if it was a yes, no, a 1, 0. Instead, we're just looking at the information up to the point of coming to that decision and trying to find, are there groupings that might tell us information? Are there patterns? Supervised is when you do need that yes or no. So it's really good and advantageous to have both approaches, because they're going to notice different signals and different patterns. Those are relevant for dimensionality reduction. So often in the world of finances, there are many, many variables, many features or columns, which means you have very big data sets, and you need to kind of chop that down, make the data set smaller with fewer columns that are the most relevant. So dimensionality reduction comes in there, and that plays a part when you are making both unsupervised and supervised models. And we'll use both linear and nonlinear pattern detection. So these are different types of supervised models. Linear, you can think of if your points kind of go up in a line sort of fashion, a linear model might be a really good fit because it is the line of best fit. If your data is not in somewhat of a line visualization, if you will, but maybe instead it has a peak and then it might drop off a little bit and then it's going to go back up and peak again, and kind of this wave look, then a line's not going to be as useful, and maybe you do some kind of nonlinear pattern detection. So once again, it's good to use both perspectives to try and capture as much of the information available as possible. And we work in what's called the regulatory tech domain, or the reg tech domain, which basically is a way of saying that the government puts out different mandates about how money laundering and sometimes insurance fraud is treated. So we'll see some of the common ones that will come up is the Bank Secrecy Act. I believe that was in 1970. The Patriot Act, that was in 2001, and they put out different mandates, different requirements of how these financial crimes are treated. So there's reporting that needs to be done to the government. There's a level of transparency and explainability that is necessary so that these investigations can run as smoothly as possible. And when you think about machine learning and you're making all of these models, and we hear about the term, a black box algorithm, where the black box algorithm can be really hard to understand, and it's called black box because it's not transparent. And in the reg tech space, you have to be aware of the fact that can bump up against some of the regulations. And so when you're putting together models in this domain, it's important to make sure that there are ways to make the predictions more explainable. So you can say, this is why Eliza got this prediction. This is why Laura got a different prediction. And you might do this in a couple ways. There's some different techniques that they're out there in the world of data science across the internet, different packages you can use. It might influence which models you choose to implement, but that's one of the things that we always have to be very conscious of because of the rules of this space. And then just quickly at the bottom to walk through, we use open source languages. So most commonly, I'll use PySpark and Python. Sometimes I'll use Scala and R. And the tools that I most often are leveraging, we have GitHub for version control. Jupyter notebooks are a really nice way to run your code while also kind of making it look like a report. You'll run a little code block and then a nice output will pop up, and it's this this sheet that you can hand off to someone and they can read through in a really nice way. Atom, Eclipse, PyCharm, those are all good ways to kind of work on your code. And then sometimes we'll use Spark shells to directly engage with the data. And so finally, on this last slide, and I'm still watching the chat, but I haven't seen any questions pop up in the last couple minutes. Let me know if I'm missing one though. I just wanted to talk to kind of the day-to-day cadence on the FCI team. So we run with agile development, and there are lots of different ways to develop. One way is called the waterfall development, and y'all might already be familiar with it, but a lot of times we'll see this in waterfall, we'll see a business requirement put out. There's a lot of definitions of what's going to be done up front, and then the developers will go out and they'll execute those needs. They'll code up some kind of solution and they'll hand it off at the end to the client. So you might think of that as at the beginning of the semester, your professor gives you an assignment and says, you need to write code with X, Y, and Z, and it's due by the end of the semester, and you take it and you work on it, and you might not ever go to office hours to check in with them. You just kind of have that initial vision, and then you turn it in at the end. So that's one way to do development. We try to use Agile, and almost not only every corporation, but every team within an organization tends to have a little bit of a different interpretation and execution style of Agile. So Agile for one group might look a little bit different for someone else, but in general, you'll try and create, you'll try to define different users for whatever problem scope that you are working with, and you'll create different personas for them. There might be multiple ones involved. You'll try to understand who they are, what they're doing day to day, how they do their operations, what they're thinking, what their pain points are. And you create this persona in the relevant workflow to try and understand how you need to develop a solution that best fits their need. And you often see lots of little spurts and iterations of trying to develop. So you might, instead of working all semester before checking in, you might instead do 2 weeks of work, often called a sprint, to try and put in a little bit of new product code. And then at the end, you go back and you check with the stakeholders and you say, okay, this is what we did in the last few weeks. What worked, what didn't, what changes do we need to make? And by the way, do you agree with the vision for the next sprint? So that's kind of what we try to do. We run in 2-week sprints. We have sprint planning at the beginning where we set out the tasks for the next 2 weeks. We have scrums or stand-ups where every day we get together and we update each other with what progress we made in the last day. We have playbacks at the end where we'll get on some kind of meeting or call and we'll share the progress with all the stakeholders. And we'll also have retrospectives at the end of sprints where we'll say, okay, what worked well and what didn't, what can we learn, and what do we need to be aware of for the next sprint. So you can see the picture on the right is a snapshot of someone in a design thinking workshop. They are theoretically, in this case, they might be defining some of the personas that we see come up in agile development. So just quickly we'll run through, because I know we're really getting close to time, what the life cycle of the data scientist looks like on FCI. So if we hit next, I just wanted to outline some of the steps that my work will often go through and who I collaborate with each step. So a lot of times if there's a new requirement to put maybe a model in, the data scientists will go and research the model, the requirements. We'll also do exploratory data analysis, where we're really kind of trying to dig through the data sets that are available to determine if something is feasible or not. And we collaborate with the team architects. They're the ones with the big plan, the big vision. Next, we'll try and prototype the model. We'll code it up, see what's working out and what's not. Typically, we collaborate with one another. At that point, we might do a little bit of that check-in and review the business value with the SMEs, or the subject matter experts. These are the ones that are going to have all the knowledge about everything financial crimes. So this is offering managers, people on the sales team. And one of the nice things about getting to work with them is you expand your domain knowledge. So that's where I learned a lot of the things about the BSA, the structuring and smurfing. Another thing from the insurance side that I learned is that there is such a thing as hard fraud and soft fraud. So hard fraud is when you are really consciously trying to create some kind of a fraudulent situation. So maybe you planned a crash, you planned a car crash and you want to benefit from the insurance company off of that. Or maybe a vendor is purposely overcharging for their services. Soft fraud is when you did not plan for whatever happened to happen, but you just kind of exaggerate a little bit. So maybe you did not intend to get in a car crash, but as you're filing your claim and you're writing down all the damage, you're just gonna add the bumper that really fell off 2 years ago, but you want to get it fixed, and why not get it fixed now? That's an example of soft fraud. And as a data scientist, it's really helpful to know that and to understand, are we meeting the business values for each, how they might differ, and we'll get that knowledge when collaborating with the subject matter experts. Once we do that, we'll try and productize the model. So that's what we talk about, modularizing, making it more efficient. We work with data engineers. We'll test and integrate it so that it flows nicely in the full software flow. Once again, the data engineers, they are our best friends. There might be a need to generate some reports or create a presentation. We'll work with the offering managers, who are kind of the face and the representation of the product. And every once in a while, there's going to be an ad hoc need to address bugs and defects that come up in the software. And a lot of times we'll work with software engineers or the customer support team at that point. They are frequently the ones that discover where a mistake has happened. So we collaborate with them to try and fix it. And all of that to say, that is kind of the life of a data scientist in FCI at IBM. I know we went through a lot of information, so if y'all do have any questions, please feel free to shout them out, and I'll try and answer as best as I can. But thank you guys for listening.
Any students have questions before I ask I came up with two just while you were talking. Why would somebody who's mathematically inclined say yay to data science? Like, what would a short little clip as to, like, yeah, I can do math, but why go into data science?
Well, I mean, so they are very closely tied. I think that one of the great things about data science is that it is a very hands-on applicable field. So some of the people in the world of mathematics that I've come in contact with, there's a lot of theory, there are a lot of kind of higher principle thinking, if you will. And for some people that works really well. I really enjoy the hands-on approach where you can take your mathematical skills and apply it to some kind of business problem and get a direct outcome. So I think that the two fields are really well tied together. And some of it might come down to what your preference is and how you work and what kind of solutions and outcomes you want to produce. But data science is really great in how actionable it is.
And then my other question was, since you were so recently, removed from school, what skills from undergrad particularly, either soft or classroom skills, that you feel were most useful that you gained that moving forward into your job have been most helpful?
So I think that, and it's been touched on in this call already, but what we would call the soft skills are incredibly important, because you might have the fanciest algorithm with the best accuracy metrics possible, but if you can't communicate to someone why it's useful, then no one's gonna be very likely to pick it up and use it. And so being able to understand who it is that you're talking to, what it is that they are interested in learning, and how best to translate that knowledge is super important for advocating for whatever you are working on. So I think that's one. I think one of the things that I wish I had learned more of in undergrad was the different principles for code development. Coming from the world of social sciences, I had less of an understanding of what it meant to write scalable code, repeatable code, code that's modularized. Some of my counterparts who spent more time in the STEM fields, they're able to draw on that knowledge, and thankfully they teach me. And I think that that's very important for being able to make sure that your product runs cleanly and smoothly enough that someone wants to use it. So I would say that those are probably two of the top things that I'm glad I learned, and I wish I had spent a little bit more time learning.
And I guess lastly, as a woman in tech, what has been the biggest challenge that you have faced?
That's a really great question. I would say that, thankfully, the world of STEM is becoming more diverse, but it is not an overnight transformation. And I think that there are still some older expectations and perspectives of what the STEM field looks like. And so being cognizant of that really helps when going into different situations where you might need to advocate for yourself a little bit more. You might need to really be able to defend what you coded and why you coded it. So I do think that those patterns come up depending on the situation. But I think what's really nice is that now that the STEM field is diversifying so much and there is more dialogue around what that looks like, the opportunity to find allies and other people that will advocate for you and kind of not only allow you to speak up, but support your voice is becoming more and more prevalent, which is great to see.
Yay. Any other questions from other participants? All right. Well, I wanted to thank both Lisa and Eliza for your time. This has been great. I have learned so much about data science, especially. I knew the title and I thought I had an idea, but I didn't. So I'm really grateful for both of you for coming out and talking to all of us today. This video will be edited and then put up online because it'll take out my chit chat at the beginning. So this will be up. So feel free to go back and watch this. If you want to learn and pause and learn more about data science, especially, go back or learn more about IBM. Lisa had tons of great slides about what is IBM and that sort of thing. So thank you for coming out.
Did I see that somebody raised their hand? I thought I saw a symbol where somebody raised their hand.
Marlissa raised her hand.
Yeah.
Where are you and where is your
Yes, I have a question.
Sure. Yes, whenever.
Hey, so IBM has So IBM has the highest number of patents that have been approved IBM products. Like, who are your main customers? I think that was the question that I had been trying to ask.
Well, yeah, and in terms of the main customers, kind of that first slide, like 9 out of the top 10 banks use IBM products. You know, I forget the statistics. Probably any bank you can name has IBM products. Most insurance companies, a lot of big businesses. The other area is many airlines continue to use a reservation system that IBM had developed. So lots of big businesses, I would say.
This
I
video,
was not aware. Thank you.
this video, it will be posted on the WiSDEM's YouTube site. I don't have the link right now, but we will. You're in my class. I know you're in my class. I'll make sure y'all get the link later on. Okay. Any other questions?
Tried to ask a question a while ago, but had forgotten to unmute.
Okay.
So is data science, if you decide that's the field you want to go into, what would be some entry-level positions that would lead you into data science field?
Really great question. And and I realize that we're running over, so I apologize, everyone. I know I talked a lot. One of the great things about data science is it is becoming more diverse in the ways that people interact. So we're seeing, you know, while I went through a formal education institution, there are lots of Coursera courses online. That's a really great option to kind of do some at-home learning. I would say, I'm trying to think through some of the different titles. I mean, you'll see junior analyst, you might see some kind of business analyst. The business analyst might be a good way to have a taste of that technical and then move a little bit more into the data science specific techniques as you move through your career. I've also seen people take it from the other side. They'll enter as software engineers where they are kind of more on even back into the front end, but the work that the product that they're on isn't analytics involved, and just naturally through day to day, you're able to kind of start picking some of that up. So I would say if you want a specific job title, something with analyst, information analyst, business analyst, data analyst, those might be good options. But I have seen those with traditional computer science backgrounds do on the job kind of pivots because they've gotten exposure through their position.
All right. Any other questions? I'm not trying to cut anybody off. Questions? Okay. Thank you all so much for being here. I'm very grateful. Stay warm, stay dry. We had sleet earlier in Chapel Hill. I don't know what it's doing everywhere else, so be careful out there. All right.
Thank you for having us, everyone. I appreciate it.
So much.
Thank you all. Have a good day.
Bye.
Bye.